In this video, we are going to continue our discussion of IVPs by working another example. I wanted to work this one because we have that, I believe it's phi, but we have a Greek letter, and it usually throws my students off. They will use this letter to show guesses, especially the text that we are using if you're going to read those sections or work any of the problems from that. And even in our own problems that I will give you, sometimes they will take a guess or a possible solution and call it this. I just wanted to show you, this problem said verify when I first typed it up. It just takes a long time to verify. We're not going to go ahead and verify. We're just going to work on finding C's, the C1 and C2, so you can get some practice with that. I'm sure that you guys can take derivatives and plug it in. All right, so we have our possible Y here. That's what that is. And they said given, so we're going to say, okay, that is our Y. So let's take our phi here. Forgive me if that's not phi. I blanked on the Greek letter. So I have c1 e to the x plus c2 e to the negative x, and I can actually also find the prime of that. C1 e to the x just becomes c1 e to the x because derivative of e to the x is e to the x. The second one, though, I get a chain rule, and it's going to cause a negative to happen. So verify that, make sure you're good, and you understand why we got a negative. All right, we don't have to verify, thankfully. We're not doing any of that. We're just going to use initial conditions to solve. So I'll show you how this works out. Using y of 0 equals 1, we have, okay, so 1 equals, I'm just plugging into the equation directly above it. C1, we have e to the 0 plus C2, e to the 0. Those are my x's, right? X was 0, y was 1. And this leads me to getting 1 equals, do not say e to the 0, 0, please. It's 1. If you're ever unsure, use your calculator. So I get 1 equals C1 plus C2. Now you're probably like, well, the problem that we've done before this, we were actually solving for C1 first and then working forward to get C2, but I can't solve for C1 or C2. So we're not going to do that yet. We're going to see if we can create what's called a system of equations, which you guys have done in algebra. So now using the other one, y prime of 0 equals 2. So I'm looking at the second equation on the top right. So I get 2 equals, and then I'm plugging in 0 for these, so it's the same idea. C1 minus C2. Let me show that work there. E to the 0 minus C2 e to the 0. And that gets me 2 equals C1 minus C2. Now, this right here, let me highlight, is a system of equations. You guys did this back in algebra. Some of you guys may have done this with matrices, but this had like different techniques to solve this system. Right, so there's my system of equations. We had things like elimination, substitution. You could solve by graphing, which nobody ever chooses to solve by graphing. This one works out perfectly for elimination. Notice if I just add straight down, I can do that with equations. All right, if things are equal, I can put them together and they're still equal. So 1 and 2 make 3. C1 plus C1 is 2C1. And then the reason we did this is C2 minus C2, gone. So now I can solve for C1. C1 is 3 over 2. And then I use that top equation, 1 equals, 3 over 2 plus C2. And I solve that to get C2. If I minus 3 halves, I get a negative 1 half. So there are C1 and C2. Oh, I said them backwards, but you get the point. So a lot of times for these IVPs, we will be working a system. So we need to get good at these algebraic systems. Now, most of the time it works out like that. It's not going to be anything crazy. A little later it does get nasty, but not too bad. All right, we're going to do another example of this. So using those same, I'm going to write down those functions again. So phi of x equals c1 e to the x plus c2 e to the negative x. And then we also have phi prime of x equals c1 e to the x minus c2 e to the negative x. Okay, so using those to each one, y of 1 equals 0. That's going into the top equation. I get 0 equals c1e plus c2 e to the negative 1. So I'm going to put a 1 on that first one. Plugging in once. Okay, now we have y prime of 1 equals e. All right, so that's e equals, Oh, there's nothing to simplify on that first one, if you can see it, right? Plugging this one in, I got E for Y, right? Or the phi prime, Y prime. So I got C1, E1, plus C2, or minus C2, e to the negative 1. This works out really nice in our system. Here's another way to note a system we have there. If you add down, it works out in our favor. Because the C2s will go away, we get 2C1, E1. If I divide by 2E, this gives me C1 is equal to 1 over 2. Divide both sides by 2E, the E's cancel, we just get 1 over 2. Now I can use one of the equations that I have to solve for the other one. I'm going to use the top one because it feels easier to me. So I got 1 half E plus C2, e to the negative 1. I'm going to minus the 1 half E. So I got negative 1 half E equals C2, e to the negative 1. How I get rid of e to the negative 1 is I just multiply both sides by e to the 1. So I get negative 1 half e squared equals C2. So here's C1. And here's C2. It's not pretty, but we can leave it. We don't want to take the E and plug it in and get a decimal. We like exact better. So systems, and some of them look nasty. This looked nasty, but the elimination method worked out perfect for that. We didn't have to deal with that E to the negative 1, thankfully.